Welcome back to my devlog for Aerodyn, a 2D platform I've been working on for the past couple of months for my college capstone. As I wrap up my development on this project, I'll be making a few retrospective videos looking back over my design process and discussing lessons I learned along the way. Today we will be discussing one of the most complicated parts of game design, programming. But since I'm not really much of a programmer, and it's much harder to demonstrate visually than art or level design are, I'll also be covering a related topic, scope. In this video, I'll first go over some of the programming highlights of this project, then go into how programming relates to game scope and focus. I guess it's ironic that in this video on focus, I'll be splitting my attention between two topics. Anyway, there's no point in stalling, so let's just get into it. Aerodyn has had plenty of programming complexity from the start, and most of it originates from one file, the player controller. My games tend to pile a lot of the mechanics into an intricate character movement system, and this project features by far the most complicated one I've ever designed. I'll try to dig into some of the most interesting design tricks I employed to get this project off the ground. At the very core, the character controller is a state machine, a programming structure that splits functionality between distinct, states. In this case, each state describes the current action the player is currently performing, idling, moving, using an attack, and so on. The state machine allows otherwise impossibly complex systems to be broken down into two basic questions, based on the current state. What should I be doing in this state, and under what conditions should I change state? It's this system that, for example, differentiates between jumping in the air and jumping from the ground, or pressing in the attack button as opposed to releasing it. The game first checks the current state, then notes whether a specific action should be based not only on that state, but also the player's input, the character's position and speed, or finite game resources such as breath or health. The game actually has a few overlapping state machines, one that controls the current action the player is doing, a second that determines the element the current player can use, and the third that separates system controls for player animations. These all work alongside each other to define otherwise impossibly complex interactions. Okay, so that was quite a bit all at once. So let's look at a simpler programming feature, player inputs. The game actually accepts two types of inputs, game controllers and mouse and keyboard. The game reads inputs provided by Unity's input manager, which can read from either of those sources, and can recognize analog joystick inputs, button presses, and the like. Since I was working with the older input manager that I was more familiar with, I ran into a few problems. For example, the system can't detect when a button has just been pressed or released. This was important for my project since a few game mechanics relied on negative edge, or the input received when releasing a held button. For instance, the player can hold the attack button to aim a projectile in any direction, which is only released after, releasing the attack button. To address this issue, I implemented a few additional variables to the player script for each button. Each input already has a value stored as a boolean or float value, basically a true or false or a number, and those depend on the button type. For each button-specific variable, there are also two additional booleans that activate when a button input changes from pressed to released, or vice versa. It was a bit complex to set up, but once it was done, it's as simple as referring to those booleans to tell when a negative edge input has been received. Of course, I would define this functionality in a separate script if I had to do it over again. That way, non-player objects, such as menus, could also read the same inputs. Or I could just learn to use the new input system, whichever one comes first. There are a few other coding features I'm proud of, such as the overall feel of dashing or diving, as well as the ability to link multiple objects to the same switch or pressure panel through the inspector. but going into all those mechanics would be more time than it's worth, especially once I discuss how a lot of these mechanics never made it into the final game. That's right. Just like the over-detailed character sprite that I made for half a semester, the character controller also contains plenty of unused functionality. The player's options to switch between different elements, pretty much useless since there are no sprites for elements outside the basic wind. That also meant that the various game objects designed to interact with these elements also went unused. The player even has the ability to throw multiple types of projectiles with different speeds and trajectories and everything, but none of them are used. Even the basic projectile doesn't have finalized art to go with it. Ultimately, both the overcomplicated character controller and unused character sprites tie into the same problem: overscoping. Overscoping happens when a project is slated to include more features and context than can be incorporated given the time and resources available. It's actually pretty difficult to predict just what will be required ahead of time in a game due to how complex and interconnected the design process is. It's why project managers are an integral part of game development. Unfortunately, I'm not much of a project manager, so I did what I usually do. I overpromised and overcommitted. It didn't help at all that this game was something of a passion project for me, and that I wanted it to be the absolute most perfect version of itself. But when you're also trying to pass 4 other upper-level classes, plan for your postgraduate life, and even produce this series of videos on the side, there are limits to what can realistically be done. So at the halfway point of development, when I realized my ideal vision of the game wasn't attainable, I had to seriously consider what areas I wanted to focus on. I've already covered those in past videos: art, level design, core mechanics. These were the aspects I wanted to highlight as much as possible in the final product. If I had started out with this focus from the start, I could have simplified the game design to better represent the core mechanics, or simplified some aspects of the visual design to create a more unified product. But given what I had to work with, I'm satisfied with what I got. That about covers the programming side of my project. In the last video of this series, I'll be wrapping up this retrospective with a serious discussion about scheduling and motivation, one of the most important lessons for me to walk with as I move forward. Hope to see you then.